Hello students, in this video as part of basic electrical engineering revision series for EC and mechanical students for TS GENCO examination, I will be discussing DC generator practice bits. So before discussing the DC generators practice bits, I will discuss the DC generators concept in very brief and will concentrate more on the practicing the questions of the DC generator. So we all know DC generator is a electromechanical energy conversion device. So DC generator will convert input mechanical energy. Input mechanical energy is nothing but what? Rotation. And it will convert mechanical energy into output electrical energy. Electrical energy is nothing but what? EMF. So DC generator converts mechanical energy into electrical energy. Mechanical energy is nothing but rotation. Electrical energy is nothing but what? EMF or voltage. And DC generator mainly it has two parts, stator and rotor, and it has armature winding as well as field winding. So in the basics of electromagnetic induction we have discussed that to get a EMF in any conductor or circuit we need flux and we need conductor and we need relative speed between conductor. That means flux and conductor both should not rotate at same speed. So in case of DC generator, conductor will be rotating and flux will be stationary, so that we will have the speed difference between conductor and flux, then we will get the EMF induced in the conductor. So we say DC generator works on the principle of electromagnetic induction. So DC generator works on the principle of electromagnetic induction. What is the meaning of electromagnetic induction is whenever conductor cuts the flux, EMF will be induced. So this rotating conductor is going to cut the flux, then EMF will be induced. So that EMF is nothing but what? Electrical energy. Briefly we will see what is the construction of DC generator. See this so mainly we need field winding and we need armature winding. Field winding is to develop the flux, and this armature conductor, see all the parts of the generators are covered by one protecting cover to protect all the parts from the dust or moisture. So that protecting cover, this outside protecting cover is nothing but what? This is called yoke. So this is nothing but what? Yoke. So yoke has one purpose is it will protect all the parts of the generator. It will be covering all the parts of the generator. And second purpose of the yoke is it will give the mechanical support to the these poles. So these poles are attached to what? Yoke only. So that is about the yoke. And yoke is made up of like if the generator size is more, the generator weight is more. So in such case weight is the main criteria for us. In that case yoke is made up of cast steel, because steel will have the less weight. So yoke is made up of cast steel. When the weight is not a big criteria, when the cost is main criteria, in that case we'll be using the cast iron. So weight is not a problem, but we have to take the cost into the consideration. In such a case we will use a cast iron for making the yoke of the generator. And next thing is about the how the flux will be developed in the DC generator. For that we have pole core, we have pole shoe, and we have the field winding. These three parts, pole core and pole shoe. And you see the pole is like this. So this is called pole core. It is made up of solid material, and this is a pole shoe. So this part, in this particular shape, it is made up of pole shoe. So the purpose of the pole shoe is it spread out the flux onto the armature conductors. It makes sure that it spread out the flux onto the armature conductors. And this pole shoe is laminated so that eddy current losses will be minimized. And here this field winding is placed on the pole core. Here field winding will be placed on the pole core. And this pole is not this pole is not a natural magnet, it is a electromagnet. So electromagnet means externally we have to give the power supply to form the flux, So this field winding will be given external power supply so that it gets magnetized. So this is about the pole core, pole shoe, and field coil or field winding. And second thing we need is armature conductors or armature winding. You see, this is the small things are nothing but like this. These are armature slots. This is armature conductor or armature winding. So this is armature. This armature will be rotated by the prime mover. So in DC generator we have stator and rotor. That rotor is nothing but this particular armature. This armature or rotor will be rotated by external prime mover. Like in case we use some turbine. When the water hits the turbine will be rotating. That rotating turbine is coupled to this armature. Then armature will start rotating. On this armature we are placing the armature winding. So when this armature started rotating, this armature winding cuts the flux. Then EMF will be induced in the armature winding. Now EMF is induced in the armature winding, but this armature winding is rotating now because it is placed on the armature rotating part. Then how to collect this particular output from the armature winding? So if I collect output from the rotating part directly, then it will create the sparkings. So then we'll be using the one important thing is called commutator, and one more thing is called brushes. So whatever the EMF induced in the rotating armature conductor, that EMF is not DC, that EMF is nothing but what? AC. And this AC EMF is converted into DC with help of commutator. The purpose of the commutator is it converts alternating EMF in the armature conductor into DC, and that DC is given to brushes. So the purpose of the brushes is to collect the output from the rotating armature conductors. So that is a use of brushes, and brushes are made up of some conducting material like carbon, and commutator segments are made up of the conductor like copper. So this is briefly about the DC generator construction. See, what are the types of DC generators? So there are two types of DC generators. So what are the types of DC generators? So first one is separately excited DC generator. Separately excited DC generator. And the second one is self-excited DC generator. Self-excited DC generator. So what is the meaning of separately excited DC generator, self-excited DC generator? We told that in DC generator we have the field winding. That field winding is going to produce a flux, but it is not a natural magnet, it is a electromagnet. That means to produce a flux we need to give the power supply to the field winding. So based on how we give the power supply to the field winding, based on how we give power supply to the field winding, based on how we give power supply to field winding, we have two types of generator, that is separately excited DC generators and self-excited DC generators. Based on how we give the excitation, giving power supply is known as giving excitation. So first one is separately excited DC generator. So the name itself it is saying, let us say armature winding I am representing in the form of a circle, and these two are the brushes, and let us say this is armature, and this rotating, and we need a field winding. This is a field winding. Now the question is how we give excitation to this field winding. In separately excited DC generator we give the power supply externally with the help of some battery. So this is, let us say, battery supply voltage V, and this is a field current, and separately excited, and this field winding is given power supply from the separate source, and whenever this armature started rotating it cuts the flux, and EMF will be induced in the armature, that is EG, and let us say we have connected to the load. So this current is nothing but what? Armature current, and current flowing through the load is nothing but what? IL. So let us say voltage across the load I am calling as V. See, whenever this rotating armature conductors cuts the flux produced by the field winding, EMF is induced in the armature conductors. So armature output is not connected to the field winding. So how the field winding is getting the power supply? From the separate source, that is called separately excited DC generator. And what do you mean by self-excited DC generator? Self-excited DC generator means the output of the generator is given as input to the field winding. That means field winding gets the excitation from the same generator output. That is called self-excited generator. Let us say you are starting a business. So for your business, after starting a business, we get the some profit. Again, that profit will reinvest. So initially the investment we got from some other source, that is separately excited DC generator. Now in self-excited DC generators, in self-excited DC generator, we have again three types of generators: self-excited DC generators, self-excited DC generators. We have three types. One is DC shunt generator, and other one is DC series generator, and third one is DC compound generator. So based on what criteria we have classified into three types means, in self-excited generator, how the field winding is connected with the armature winding. Based on that, we classified into three types. If the field winding is connected in parallel with the armature winding, called shunt generator. If the field winding is connected in series with the armature winding, it is called series generator. One field winding is connected in series with the one field winding is connected in series with the armature, and one more field winding is connected in parallel with the armature, that is called compound generator. Again, in compound generator we have like long shunt compound generator, and we have short shunt compound generator. So based on the how we place the winding, we have long shunt compound generator and short shunt compound generator. Now about how to construct the diagram and what are the equations, briefly we discuss now. First, how to construct the diagram of circuit diagram of these generators, I'll tell you. Any generator will have two windings, any DC generator. One is armature winding, like this will represent. Armature winding means EG. EG means EMF induced in the generator, and armature winding resistance is RA, and armature will be flowing out of the armature winding, that is armature current. And any generator will have the field winding, so we represent field winding like this, and we represent the load like this. Voltage across the load, we represent the terminal voltage, and current flowing into the field winding, because always this field winding takes the power supply to develop the flux. Always current will be flowing into the field winding, and armature develops the voltage, and current will be going out of the armature winding. And field winding resistance we call as what, RF. Now this is armature winding, these two are nothing but what, brushes, and this is a field winding, this is a load. So now we'll start constructing the diagrams. So first let us start with the separately excited DC generator. So as already we know, separately excited DC generator, field winding is given power supply from separate source. So this is the source, this source voltage is V, field winding resistance is RF, field winding current is IF, and here we have armature winding. Armature means circle, on the top two brushes. This is EMF generated in the armature EG, armature winding resistance is RA, and it is connected to what, load. So current flowing out of the armature is IA, and current flowing into the load is what, IL. This is load. And voltage across the armature is what, voltage across the load is what, V. As current is entering at the top, this I am treating as positive and this I am treating as negative. And current is leaving here, this I am treating as positive and this I am treating as negative. Now I want to develop the relation between IA and IL. And you see, as armature and load both are there is no division of the current here, then first equation is IA is equal to IL, armature current is equal to load. Now I want to develop the relation between the armature voltage and the load voltage, whether total armature voltage generator is given to the load or any voltage drop is happening. Let us understand. So to develop the relation between the voltages, we have to apply the KVL. So I am applying the KVL in this direction from armature to the load. I am coming across what polarity first, negative, so minus EG. And here in armature winding resistance, current IA is flowing, there will be some voltage drop. So minus Eg plus IaRa. So voltage drop in the armature winding resistance is IaRa, and we are coming like this, and we are coming across positive polarity, therefore plus V is equal to 0. So what is the voltage equation of separately excited DC generator? Eg is equal to V plus Ia into Ra. Let us say some 220 volts voltage is induced, some 10 volts is the voltage drop in the armature winding resistance, only 200 volts will be out of 210 volts will be given to the load. So total voltage is not given to the load, some voltage will be wasted in the armature winding resistance. So Eg equal to, we got V plus IaRa. So from this Eg is equal to V plus IaRa, I want the armature current value. So Eg equal to V plus IaRa. This implies Ia is equal to this V, I am bringing this side. So Ia is equal to, what is the formula? Eg minus V divided by what? Ra. This is the armature current formula. So this is about separately excited DC generator. Now let us start with self-excited DC generator. So in self-excited DC generator, for the field winding, power supply is given from the same generator itself. Now the question is, so how that first output will come? See, in self-excited DC generator, what we are telling, DC in self-excited DC generator, the same generator output is given as input to the field winding. So output nothing but what? EMF we need to get. So to get the output EMF, we need flux. So that flux has to developed by the field winding, means it needs power supply. So we need to get the output, means we need to have the input to the field winding. How we are getting? So that let us understand. See, I am taking DC shunt generator example. So DC shunt generator I am writing. This is the armature winding, and this is the field winding, and shunt generator means both are connected in parallel, and this output is given to some load. So now whenever this armature conductors started rotating, that will cut the flux provided by the field winding, then we will get the EMF, then we got some output, and it will produce current Ia, and it will go into field winding as well as it will go into load. But the question is, to get this easy, we need to have the power supply to the field winding. So how we are getting that initial output? How we are getting this initial EMF? So without this power supply, without this current through the field winding, already in the field winding, because of the previous magnetization, it will be having some flux. That flux is known as residual flux. That flux is known as what? Residual flux. When these armature conductors rotating, they cut the residual flux. So initially we get some residual voltage ER. Let us say this residual voltage equal to 10 volts, and this residual voltage will cause some current Ia, and some current will start flowing through the field winding. Then this residual flux will be increasing, and as the flux is increasing, again EMF value is going to increase. That means in self-excited DC generator, initially how we are getting the output means due to the residual flux. Let us say if residual flux is absent, if residual flux is 0, then what we have to do? Obviously we have to give some power supply to the field winding externally. Okay, so this is called voltage build-up process in the self-excited DC generator. That means initially residual voltage is there, and because of this voltage, it will produce some current through the field winding, and as the current through the field winding is increasing, flux is going to increase. Flux increases means again this EMF will increase to some 20 volts, and it will go up to rated voltage. This is called voltage build-up process in the self-excited DC generator. So if this voltage build-up process in the self-excited DC generator has to happen successfully, means so we need to have the residual flux mandatorily, and we need to have our field winding resistance must be less than the critical field winding resistance, and our armature winding and field winding are both are connected properly, and armature winding is properly rotating in a proper direction, so that the voltage induced is going to be more. So whenever these three conditions are satisfied, then only this voltage builder process will be successful. So this is about how the self-excited DC generator works. Now we'll start working on the equations of self-excited DC generator. So first generator we are talking about is DC shunt generator. So how we will construct the diagram? Let us see. So any generator will have two windings. One is armature winding. So this is armature winding. Armature winding resistance is Ra, two brushes, and field winding. This is a field winding, and this is nothing but what? Load. And as it is a DC shunt generator, field winding, armature winding, and load, all the three things must be connected in what? Parallel. Parallel means all the three things first ends are connected at one common point. All the three things second ends are connected at other common point. This type of connection is known as parallel connection. So here field winding resistance is RSH. How the shunt field winding is designed? Shunt field winding is designed with more resistance. Why more resistance? RSH should be more. Why RSS is more? If RSS is more, less current flows through the field winding and more current will be flowing through the load. So how the resistance will be more? R is equal to rho L by A. Length has to be more. That means number of turns has to be more. And cross sectional area should be less. That means less diameter. So shunt field winding is designed with more number of turns and thin wire. Thin wire means less diameter, less area, more resistance. Okay, so this current is load current, and this current is shunt field current, and this current is nothing but what? Armature current. Now we'll draw it again and we'll start working with the equations. So this is the armature winding, this is EG, this is shunt field winding, this is load. See, this is IA, this is plus minus, armature winding resistance is RA, and this is voltage across the load is V. This I, let us say this is node A. This I is dividing into two parts. This is ISH and this is IL. See, this armature winding resistance I'll represent like this, RA, and this is armature. As current is entering, this is plus and it is what? Minus. First of all, I want to develop the relation between the three currents, IA, IL and ISH. See, IA is the incoming current, IL and ISH are the outgoing currents. Apply the KCL at node A. So KCL at node A. Sum of entering currents is equal to sum of leaving currents. So what is the entering current here? IA. And what are the leaving currents? IL and ISH. So IL plus ISH. So the relation between IA, IL, ISH in shunt generator is IA is equal to IL plus ISH. And now I want to develop the relation between the voltages, that is EG and V. So to develop the relation between the voltages, I have to apply the KVL. So here load is there now. This is plus and this voltage is nothing but what? V. So this closed loop I have drawn here. So first I am starting from this minus. So I want to apply the KVL. So for voltage, the polarity is going to be minus. So minus EG, and these brushes will be having some drop, that VBD I am calling, voltage drop in the brushes. And when I am coming like this, positive polarity is coming, plus voltage drop in the resistance is IR, IA into RA, plus IA into RA. and when I'm coming like this, I'm coming across positive polarity first, so plus V is equal to 0. So usually voltage drop in the brushes is small, hence it is neglected. Then Eg is equal to, what is the formula? V plus Ia into Ra. This is the voltage equation of DC shunt generator. And what is the ISH value? This shunt field winding resistance is what? RSH. So current, usually what is the current formula? I is equals to, what is the current formula? V by R. So ISH is equal to, here I'll write ISH. ISH is equal to voltage across this shunt field winding. This shunt field winding is in parallel with the load, is in parallel with this branch. So in parallel connection, voltage is same. So voltage across the shunt field winding is equal to voltage across the load. Voltage across the load is what? V. So ISH is equal to V by, and resistance is nothing but what? R. V by RSH. Shunt field winding current ISH equal to V by RSH. So this is about the DC shunt generator. Next we will see DC series generator. Next type of generator is DC series generator. So see, armature winding, this is EG, is connected in series with the field winding. This is a series field winding, and here we have load. So armature winding, field winding and load, all the three things are connected in series. So armature winding resistance is Ra, current this is Ia, and this is ISE, series field winding current, and this is load current IL. Current is entering at the top, so top is positive and here negative. Load voltage is V. So what is the relation between IA, ISE and IL? So you see all the three things are connected in series, therefore Ia is equal to ISE is equal to IL, same current. So whatever the current coming from the armature winding, the same current will flow through the field winding, the same current will flow through the load. Okay, this is relation between the currents. This is positive and this is negative. Now I want the relation between EG and V. So apply the KVL in this direction. So I am coming like this. I am coming across a negative polarity first. Therefore minus EG, and voltage drop in the brushes is VBD, plus voltage drop in the armature winding resistance is IARA, and here current is entering positive, current is leaving negative. Voltage drop in the series field winding is IR, ISE into RSE, plus ISE into RSE, and when I am coming across load, positive polarity is coming first, plus V is equal to 0. If we neglect voltage drop in the brushes 0, then we know this ISC and IA both are same. Therefore this ISC I am substituting as what? IA only. Then what I am getting here? Minus EG plus IARA plus ISC RSC plus V is equal to 0. Here IA is taken common, minus EG plus IA is taken common, RA plus RSE plus V is equal to 0. So this minus EG comes this side, it becomes EG is equal to V plus IA into RA plus RAC. This is the equation of voltage equation of DC series generator, right? So this is about the DC series generator. Now we'll start with the DC compound generator. In DC compound generator we have long shunt compound generator and a short shunt compound generator. So based on the name we can easily construct the diagrams. First, long shunt compound generator. This is long shunt compound generator. So compound generator means it will be having both the field windings, shunt field winding as well as series field winding. See, this is the shunt field winding and this is series field winding. Series field winding is connected in series with the armature. This is EG. You see, shunt field winding is in parallel with both series connection of series field winding as well as armature winding, and this is nothing but what? Load. This is long shunt compound generator. In long shunt compound generator, shunt field winding is in parallel with the long branches series field winding and armature winding series connection. And now short shunt compound generator. Short shunt compound generator, you see, this is the armature winding and this is the series field winding, and this is nothing but what? Load. Here shunt field winding is only parallel with the armature winding, only parallel with what? Armature winding. This is short shunt compound generator. And we have cumulative compound generator and differential compound generator. Cumulative compound generator means flux developed by the series field winding is going to add with the shunt field winding, and differential compound generator means flux developed by the field winding is going to oppose the flux developed by the shunt field winding. That is that is differential compound generator. And we have what are the just briefly I'll discuss what are the losses in the generator. So losses in the generator, there are three types. I'll discuss more about the losses in the motor. Losses in the generator, three types. First one is iron losses, and second one is copper losses, and third one is mechanical losses. Iron losses, we have hysteresis losses and we have eddy current losses. Both these losses will occur as armature core is rotating in the magnetic field. Flux linking with the armature core is changing, and because of the reversals of the magnetization in the armature core, heat produced in the armature core, that is hysteresis loss. And as the armature core is rotating in the magnetic field and it cuts the flux, some EMF is induced in the armature core, but it is not useful, we are unable to collect it. It will produce some unwanted current in the armature core and it will produce a heat, that is called eddy current losses. To reduce the hysteresis loss, armature core is made up of less hysteresis coefficient material, and eddy current losses are reduced by laminating the armature core. And what do you mean by copper loss is, if current flowing through any winding, because of the winding resistance some power loss will occur, that is known as copper loss. So armature winding copper loss is Ia square Ra, shunt field winding copper loss is ISH square into RSH, series field winding copper loss is ISC square into RES. These are the copper losses. And mechanical losses means, mechanical losses are two types of losses: frictional losses and windage losses. It supports due to the aging, and then some friction gets developed, and due to that the friction losses will occur. And windage loss means due to the wind friction to the armature rotation, some rotation will be lost, that is called windage losses. And we use the bearings to reduce the frictional losses. This is briefly about the DC generator, and in the next lecture we'll discuss some practice questions on the DC generator. Thank you.